So we believe that as a solar battery manufacturer, we believe that now that we've manufactured the hardware, we are 20% there. We think that the remaining 80% is software. And we've been developing our own software platform since 2019. So one of the functions, I don't know if anyone's seen this term before, but arbitrage is effectively utilizing those spot prices. We're able to download information from certain energy companies 24 hours before, and they're effectively putting solar on everyone's house, and they need a way to be able to share the power within the village. So being able to do something like this is a benefit for not only the tenants but also the landlords. So.
Hello everyone. Good morning, good afternoon, and good evening to everyone. I hope you can hear me well. If you hear me, could you please leave a message in the chat so we can see that, make sure everything's working fine. So we are very happy to have so many participants across the globe joining us today for the webinar. So today's topic, energy storage. We have a special guest. His name is Tynan Coles, and he will be talking about the latest trends in smart batteries. And just before that, we will have a very brief presentation about risk management of energy storage. My name is Driekes de Rooij. I'm the managing director at Sinovoltaics. Here with me in the room is Niklas Weimar. He's our CTO, and today's guest is our good old friend Tynan Coles from Australian battery maker Soltaro. Soltaro is specialized in both home and commercial battery storage, and today Tynan will talk about the topic of smart batteries, its applications, and key benefits. So the agenda for today, before handing the word to Tynan, our team here at Sinovoltaics will give you a very brief introduction on general battery risk management practices. We'll outline why it's so important to employ quality batteries from established suppliers. So the entire presentation will take about 30 to 40 minutes. There is a Q&A session at the end. So if you have any questions, please type it here in the chat. We'll be able to see this, and we will try to answer as many questions as possible. So let's get started. Battery risk management, best practices. Just a brief look at the market. Nowadays, the energy storage market as a whole is growing at an annual compound growth rate of 20 to 25%. Now, most of this growth, over 60%, stems from Asia Pacific. Looking at the technology over the past years, lithium iron phosphate has been establishing itself more and more as the main chemistry used in energy storage systems. Their main advantages compared to other technologies, their lower cost and their increased safety. Now, depending on your project requirements, there are other suitable technologies as well. For instance, if you have requirements related to space, you need more space efficiency, or you require a high charge or discharge rate. You can also look at different chemistries such as NMC. This can also be a good solution, but typically comes at a higher cost. Just a brief introduction, but I'm going to hand over the word to you here, Nick. And Niklas, he will be talking more about the risk management principles of energy storage.
Yeah, thank you, Driekes. So allow me to continue here. Looking at recent developments from a technology point of view, Despite this massive growth, as outlined by Drickus, energy storage as a mainstream industry is still in a relative juvenile state, in which the proper qualification of products has only picked up in recent years. So 5 years ago, only a few manufacturers would get their battery cells and packs certified to applicable, or by then applicable, IEC and UL standards. But now with updates in these standards and also increasing maturity and adoption, this is changing. And buyers have more orientation points, so to say, in the decision-making. Also in China, which is a major producer of battery cells, packs, and systems for consumer electronics, EVs, solar and ESS, and other applications, has also ramped up its regulations. For example, on the 1st of January this year, new mandatory safety regulations for EVs and lithium-ion batteries came into effect in the form of a new GB or Guobiao standard, which covers a variety of tests and or safety and performance tests, including system thermal diffusion, external fire, mechanical shock, collision simulation, and so on. So this is increasingly, from a regulation point of view, taking more and more mature shape, and also is implemented by governments all over the place to cater to the inherent risk of batteries. While new standards and increasing regulations are important to the overall standardization and, I would say, also professionalization of a still comparably Wild West industry, nevertheless, proper risk management is essential to ensure battery performance, safety, and thus also, of course, project ROI. This does not only include checking that the batteries are compliant to the required product standards, as well as logistics safety standards, but also to understand the structural setup and technical capability of the supplier and perform proper due diligence right from the start. So why do we need risk management? Well, incidents and accidents across the globe involving batteries underline actually the very importance of proper product quality and safety as priority in battery production and their transportation. This slide contains only a very small snippet of selected examples spanning over the past 10 years only. And as you can see, these involve a variety of situations, including aviation and transport and stationary systems where incidents and accidents occurred. Just with view on the aviation industry alone, and specifically United States, the FAA in the United States actually has reported over 340 aviation-related thermal incidents involving lithium batteries between January 2006 and October this year. South Korea, for example, has over the past years witnessed more than 30 incidents involving fires of energy storage systems. So evidently, adequate quality control, testing and monitoring, but also the proper usage of energy storage applications is important to mitigate such potential hazards. Also, the employment of a proper BMS that mitigates risks, for example, stemming from excessive charging, is important to be taken into account when selecting a product. Now, for your ESS project, you will certainly want to thoroughly qualify the prospective supplier before going ahead and at least address some of the very important questions of which we touch upon here in with 5 examples. So first of all, understand how much of the value chains the suppliers actually control. Like, do they just assemble cells bought from another source, or do they actually also produce the cells themselves? If assembling cells from another source, how does the supplier ensure proper quality and source of origin of their cells? The second is, what is the track record of the supplier? Who are the supplier's previous customers? Are there any reference projects to share? Shipped capacity in the previous 2 years, for example, they show how much ESS has the supplier actually shipped, and of course then it will mirror the broader recognition of this supplier and the acceptance of its products by different stakeholders in the industry. And of course, from a commercial point of view, it also will help you to understand like how much market share you will actually represent for that supplier. Now, another point of concern is the qualification to applicable product and safety standards. So are these certifications for the required product and applicable markets in place? For suppliers that assemble cells from third-party suppliers, it is recommended to actually check what certifications are in place for the various cells that they are being supplied to assemble the batteries. Also important is to understand what are the warranty conditions, which are usually given in cycles. So it's important to clarify the conditions to reach that life cycles. For example, depth of discharge, C rate, and temperature, as these can deeply impact the cycle life. And actually, when you compare two cells or two battery packs, of course, you need to ensure that the same parameters are used when comparing cycle life. Also, and as with other products such as inverters or PV modules, the warranties of ESS makers are usually only valid as long as the manufacturer operates or is, basically still existing. So that means proper financial health of your supplier is another point to take into account when qualifying a supplier. And for this purpose, our quarterly ranking reports on energy storage manufacturers may be quite helpful in this regard. Now, lastly, and also an important point to assess is whether the supplier actually has a good and actually reachable, contactable support network. There is a considerable likelihood actually of maintenance-related issues over the operational lifetime of your system or battery coming up at some point, and then having a good support network is very important. Generally, key for project developers is not only to understand the specifications and electrochemistries of their batteries in view of their project setups or use cases, but also to make sure that these specs are actually fulfilled and delivered by the manufacturer, and thus to be actually ensured through on-site quality assurance by trusted experts. Exemplifying quality assurance of battery packs, such quality assurance scope of work, which in itself is specific for various products and technology, does usually not only involve a variety of performance and safety tests, such as capacity tests, overcharge, over discharge, and average state of charge tests, but also the assembly of the right materials and verification of a compliant build of the battery. During our quality inspections and qualifications of battery suppliers, we still fairly often observe some suppliers using, for example, second-hand used cells in the assembly of their battery packs. In some cases, also cells with poorly documented origin tracing. Some of the pure assembly lines, they have poor or even no qualification process in place to ensure compliance of materials, especially the crucial cells. Now, reason behind this assembly of second-hand used cells is that they are, of course, cheaper. This should, of course, be, on the other side, be clearly distinguished from those manufacturers that actually specialize in recycling and thoroughly test used batteries for reuse for specific applications such as off-grid telecommunication towers. Now, having in brief outlined some general risk management principles for batteries and why it is so important to work with established suppliers, I'd like to pass the word on to Tynan from company Soltaro now, who will go into more detail about smart batteries and the applications and benefits.
Thanks, Nicholas. All right. So as Drukas and Nicholas said, I'm Tynan Coles, the CEO of Soltaro. We're an Australian solar battery manufacturer. We've been in solar PV since 2009 and have been manufacturing batteries since 2016. So what makes a battery smart? For us, and it's our motto at Soltaro, it's all about the software. Smart batteries are essentially solar batteries with software that utilizes such functions as lower tariffs, excess solar to further decrease power dependence of the grid. Normal batteries, they're just designed for excess solar self-consumption. So what we're trying to do is to utilize that excess energy through software to effectively get more benefits out of your solar and out of your batteries. So we believe that as a solar battery manufacturer, we believe that now that we've manufactured the hardware, we are 20% there. We think that the remaining 80% is software. And we've been developing our own software platform since 2019. And we've got a few functions, and there's a few other software providers out there who are developing functions to make our batteries smarter. So the smart home platform, what we're looking at is being able to distribute excess solar to smart devices in your home. So being able to distribute power once your batteries are full to specific appliances that could be utilizing power whilst you're away, you're at work, you're at school, whatever it is, instead of feeding it back to the grid. So the benefit to this is you're using your free power from your solar to increase the paybacks of your solar batteries. And then the platform that we're developing is effectively going to be able to control devices in your home. So like Drukas said, we've developed batteries for domestic applications as well as commercial. And our software has been developed to not only work with Soltaro domestic solutions, but also for our commercial solutions. So some of the benefits, I mean, it's not limited to these four here, but charging the batteries when energy spot prices are at their lowest and discharging these batteries when the energy spot prices are at their highest. There's a lot of energy markets now throughout the world who are allowing you to buy energy based on spot prices. And this is not just at a large industrial or commercial level. This is now at a domestic level. We get a lot of people, especially through Europe and mainly in the UK, about being able to charge power into their batteries, especially during winter time when the tariffs are quite low. Sometimes you even get negative tariffs, so the energy companies are actually paying you to take power off the grid for them. Like I said, turning appliances on during the day, automatically doing it through our software. There's multiple applications that we can distribute the power to, which I'll go through in a minute, but effectively using your excess solar instead of sending it back to the grid for limited or no benefit, we can start turning appliances on in your home. We're getting a lot of interest in actually assisting the grid, whether it's for frequency response or voltage response. We're getting a lot of energy companies and energy distributors wanting to use batteries to stabilize their grid. To actually upgrade their network would cost more than actually putting smart batteries in. And another one is community power sharing. We've got projects going on throughout the world where you've got communities where they share power behind the meter, being able to share their solar energy between individual sites has become a very common application for our smart batteries. So monitoring platform, this was basically what we built our software off. One of the things that through our background in being in solar PV was making it as easy as possible. We find that sometimes or most times that the hardest thing is, or the most problems will come from the installation side. So eliminating as many issues as possible from that side. Our easy and fast system setup has been designed around that. Doing things remotely, so firmware checks, upgrades. We're always upgrading our system. We're always upgrading our batteries. We can't be opening the box every single time to be upgrading to the latest version. So effectively, with our software, you can plug the device in, install it, and it will check to see whether or not it's at the latest version, and it'll give you the option to upgrade to it. And then it'll allow us to remotely upgrade throughout the life of your system, and also give fleet management for installers. You obviously want to be able to check your systems that you've been installing to support your customer. A lot of people actually bill their customer for this level of support. This is all built in to our monitoring platform. So one of the functions, I don't know if anyone's seen this term before, but arbitrage is effectively utilizing those spot prices. We're able to download information from certain energy companies 24 hours before, put it into our system, and then the system will be able to, based on your usage and the machine learning that we're developing within our system, to be able to charge your battery at the lowest tariffs if you need power in the morning. For example, if it's in the winter time and we know that your battery is going to be empty, and we know that you use 3 or 4 kilowatt hours in the morning, we can effectively charge your battery at the lowest tariff. And then likewise, being able to export power when there's incentives to do that, during peak times, being able to utilize that functionality as well. And then the last one is effectively monitoring weather patterns. If we know if it's going to be a sunny day, we know how much power you're going to generate that day. If we know it's going to be overcast, we know how much power you're going to generate. So we can, through machine learning and the behaviors of your system, we can be charging, discharging, however we need to better utilize your batteries, and it's all about getting better paybacks on your system. With our battery systems, we offer a 10 warranty, so that's a big bonus for us, because we want you to be cycling your batteries multiple times a day. So like what Nicholas said, in regards to warranties, that's one thing you really need to look at is cycle life, charge rates, etc. We've designed it around that. We oversize all our battery modules so we can reach these 10,000 cycle warranty. So these are the appliances that most smart batteries can talk to. We're all moving into the EV charging world, being able to utilize excess solar to charge your vehicle, or again, it could be whether it's excess solar or using the arbitrage model where you're charging your EV at the lowest tariffs, being able to utilize your hot water unit, sending excess power once your batteries are full, to your hot water unit or your heating or cooling system. The biggest thing for us is, whether you're in a warmer climate, you probably understand this, but so many times we've come home here in Australia and your batteries are, especially in the summertime, your batteries are full by about 11, 12 o'clock, and you come home, your house is hot because there's been no one home all day and you've just been exporting power to the grid all day. You turn all your air cons on and your battery's empty in 2 hours. So being able to utilize our software and obviously making it into a smart battery where we can turn those devices on, keep your house cool during the day with excess solar, keep your batteries above a certain level, so that when you come home, your house is cool and you still got full batteries to utilize for your nighttime usage. And pool pumps. Most people, if they've got solar, they'll just schedule it to run during the day. Sometimes you're having to draw power from the grid. So being able to understand when to have your pool pumps on. And again, this comes back to the arbitrage model as well. If there's not going to be enough solar, being able to have utilize those lower tariffs so your pool pump can run as often it needs to. So effectively, they're the appliances. There's always new appliances that we'd be looking at to be utilizing the excess solar from the excess power from your solar. But in the end game is lowering your bills. Having more control over your electricity usage. We're going to give control to the end user, so they can either allow us to set the profiles or they manually set the profiles. And again, they can remotely turn devices on and off. And then, like I said, the machine learning side, where we actually see the behaviors from the end user and be able to adapt automatically for them. We all know everyone who, when they first get their solar system installed for the first months, they're looking at their system on their phone every day for the first month, and then after that they probably check every couple of months or so. So we need to be able to do all that automatically for them, and no long-term costs. So there's a small fee obviously to support the software, but outside of that, the amount of money that you save in addition to the additional features that you get far exceed that. So this is the community power sharing one. This is the one we sort of I touched base on just briefly. We've got a few projects here in Australia and a few in some other markets where you've got retirement villages. You've got a landlord that charges all the individual sites for power, and they're effectively putting solar on everyone's house, and they need a way to be able to share the power within the village. So being able to do something like this is a benefit for not only the tenants but also the landlords. So instead of the power going straight out, it'll be utilised by all the individual tenants. So this is just a brief overview of our Generation 2 domestic solution. Like I said, this is ready and available. It's been ready for the last 12 months. Like I said, it's been in the pipeline for design for the last 4 years. But this is the hardware side. It's plug and play. We made it as easy as possible. We kind of claim that it is the easiest all-in-one battery system to install. We've designed it to look like an appliance. We get a lot of people, especially in Europe, putting it in their living area because they want to showcase it to everyone. And that's because we've designed it that way. It's a combined ESS, so inverter. It is both a AC coupled or DC coupled inverter system with 5 kilowatts charge and discharge capability. So, and then the smart software, which we briefly touched on. And last but not least, it's IP65 rated. That may not be applicable to some of the people here, but in warmer climates where you can actually put your solar inverters on the wall, we've designed it for that. Most of the stuff that we did was designed for Australia, and then we've just been able to replicate it across to other markets. Yeah, so the biggest thing for us is, and this is sort of why we started developing The software was, when we first looked at batteries, we knew that was the next rising tide. Being in the solar game, we saw solar PV sort of slowing down a little bit with the amount of uptake from solar. So we knew batteries was the next wave. But based on, especially from a payback point of view, we really struggled to see how it could be affordable. And we knew that without the software, it would be something that, it has the benefits of if the power goes out, our system will switch over and you'll be able to run off the batteries. The PV will still generate. So there's that additional feature, but most people were buying it based on a financial benefit. And we knew that without the software, we couldn't get to the levels that would make it affordable for most people. So that was the reason we took that direction and put all our resources towards developing software. We obviously still work on the hardware side. We're looking at some 3-phase all-in-one solutions, but effectively the software for us is the most important part of our business now. All right, that's it. Thank you.
Thank you, Tynan. Thank you for this presentation and this final thought. Very interesting how you make sure that that energy storage has a good ROI to make people earn their money back. That makes sense. I have like 4 or 5 questions that came in. There's a couple that sound very similar. So let me start with your questions, Tynan. One question here is kind of a commercial question. It's somebody's asking, where do you have your distributors or resellers around the world, and where are you looking to expand there?
Yeah, so we've got resellers mainly through obviously Australia, but most of our resellers are in Europe. We've got a few resellers in Africa, mainly in the southern part of Africa. But our biggest hubs are obviously Australia, UK, Ireland, Portugal, Spain. There's a few obstacles in regards to Northern Europe with 3-phase, but our commercial batteries work with or can be integrated with most commercial 3-phase inverters. So, but yeah, we've got resellers and installers throughout most markets. We're developing our US all-in-one solution that'll be released with our 3-phase all-in-one solution. So that'll be the next market we really want to tackle.
Then there's a question that just came in: is what is a typical end user electricity kilowatt hour price in Australia? Well, I have no idea about it. You probably know.
Yeah, look, it varies. I mean, the landscape of Australia is quite unique. There's some places that are, 7-8 hours from any major city, so their power's roughly around 45 cents Australian per kilowatt hour. So in US cents, probably about 35 cents a kilowatt hour. In metro areas, you're probably looking around 25 cents a kilowatt hour, US a kilowatt hour. So it is quite high compared to most other markets.
Right. It's quite high, huh? Another question. That's the last question. I think you partially answered it. There's someone's asking what are your future plans with Soltaro? Like how will the coming 3 years look like?
Well, like I said, the main thing for us is really our hardware team's working on the 3-phase and US version all in one. When we design our battery systems, we want to make it as plug and play as possible. So there's less areas on installation. But it's really, our focus is on the software. It's being able to develop these features that I briefly spoke about, working with energy retailers. To be honest, we get most of our inquiries are from energy utility companies, wanting, smart battery solutions so that they can, because they're the ones that are incurring these higher costs on the spot price market. So if they can utilize battery power during those peak times, typically in Australia it can get up to, almost $2 a kilowatt hour or $1.50 US a kilowatt hour during those peak times. So if they've got a VPP network where they can, dump power during that time and offset their power usage, that's what they're wanting to do. So we're getting a lot of energy companies coming and wanting a software solution for their VPP networks.
Someone is asking, any thoughts on EV battery second life for domestic storage? And it's quite an interesting question, because what you see here in this part of the world, mainland China, all the EV makers, they're actually obliged to take the batteries back, these are all brought to second life. So there's a huge market emerging for second life batteries. Do you see any possibilities there for domestic storage?
Yeah, most definitely. I mean, it just depends on how you can utilize the materials to get a second life out of it. Generally, the cells will probably have a longer design life than the electronics. So there's potential there of recycling the cells into modules. We're looking into providing a free recycling solution where we work with recycling companies who effectively do this type of second life for the battery cells. So yeah, I mean, look, the circular economy of any product these days needs to be taken into consideration before before we all start manufacturing it. So, but yeah, it's still quite primitive field, but we're looking into it and working with some really good recycling companies who will do that for us.
I see there's one more question, but this one is for you, Niklas. Somebody's asking about LFP batteries. What is the best or realistic calendar life estimate for these type of batteries?
Calendar life. So it depends a little bit on the application, of course, and also, like, for example, if it's like a stationary application, or if it's like for EVs, like for motoristic applications, for cars. So, but speaking for stationary applications, it depends very much on the also on the depth of discharge. So if you have, of course, like a 100% DOD, of course, then your cycle life goes pretty much down. Normally you would get quotes or like parameters that use like an 80% DOD as a basis, and then you end up with around 4,000 to 5,000 cycles, and then it goes pretty much then further down when the DOD goes higher. But of course there will be manufacturers with higher values, but conservatively these are the values that you could work with.
I heard a small echo there, but we're in the same room, so okay. These were all the questions. So Tynan, thank you very much for presenting today, for sharing your ideas on smart batteries and explaining more about Soltaro. Thank you very much, and we hope to see you again, maybe in the next webinar or when it allows in person. So everyone, that's all for today. Thank you very much for joining, and hope to see you again in the next webinar. Bye for now.
Visit Sinovoltaics.com to learn more.